Hello and welcome to my YouTube channel. Today we're talking about operational amplifier, and we are going to look at one type of operational amplifier, which we refer to as a summing operational amplifier. In the previous videos, I talked about operational amplifiers and the different types of operational amplifier that we have. And on the same video, I also touched on the first operational amplifier, which was an inverting operational amplifier. Today, we're talking about summing operational amplifier. And the summing operational amplifier is based on the inverting operational amplifier that we talked about. So the difference is that when it comes to the summing operational amplifier, we just add multiple voltage inputs, right? And then the input resistances, right? So if you were to just block this part out, right, meaning you cancel the whole of this part, that would just be, and you left with only this part, right? You have this V in, R in, and then that would just be an inverting operation amplifier. So we just added more input and then more input, in that case, resistances to the summing, to the inverting operational amplifier. And once we've done this, again, the objective should still remain the same here. We want to find the relation between the output voltage VO and then the input voltage sources. So if you look here, we have quite a number of input voltage sources. We have three of them, V in 1, V in 2, and then V in 3. But we want to get a formula that will relate the output voltage and then the input voltage sources. So we have. Now, how do we do that? We do this by applying our understanding of applied electricity that we talked about in the previous videos. And by looking at this circuit diagram, you can see that V1 is grounded. That means the potential at V1 here is going to be 0. And since V1 is grounded, V2 is also going to be 0 as well. It's also grounded as well. And this is because of virtual ground. Right? We talk about the fact that when it comes to operational amplifier, in order for there to be an infinite open loop gain, right? You have infinite open loop gain. All that means your output over the differential input VD here has to VD has to be 0 in order for us to have an infinite open loop voltage gain. And then as a result, you have V1 being equals to V2. And since V1 is grounded, meaning V2 is also going to be 0 as well. And we can see there, we can indicate a node here, can locate a node at this junction, because you can see this is a junction where 3 or more components are connected. So we label this as node A, and node A is an input to the inverting input that we have here, terminal that we have. And by looking at this circuit, I can see that the voltage at VA is just the same as V2, and we can write in relationship. So voltage at VA is equal to V2, and which is equal to V1, that will give us 0. Then we now apply Kirchhoff's current law at node A. If you are at node A here, you can see that I-in is entering the node, the same thing as I2 is entering, as well as what I3. The sum of current entries equals the sum of current leaving. So you can see only IF is leaving. So we have the feedback current leaving. And we can now express the current here in terms of what potential difference. So if VA1 is entering the node, so where the I-in 1 coordinated, that becomes the higher potential. Where the current arrives, that becomes the node that the current arrives becomes the lower potential. So we have where V in 1 minus VA all over R in 1 mean the resistor, right? The resistance between the two voltages, V in 1 and VA. The same for what? V in 2 minus VA over R in 1. And you can see here that will now equals to VA. You can see at node A, IF is starting from node A, then arrives at what? VO. So we take the potential, which is VA minus VO, all over what the resistor or the resistance between the two voltages. And now give us this. So we get now the output voltage equals to minus RF into brackets V in 1 over V over R in 1 plus V in 2 over R in 2 plus V in 3 over R in 3. And then we can generalize this for any number of what? Inputs, voltages, and then resistances. So that will give us this answer here as a general formula. And this is how you are able to use an inverter. We are able to use an inverter operating amplifier and then modify it by adding inputs, voltages, and resistances so that we can turn it into a sound operational amplifier. See you in the next video. Bye-bye.